Hello everyone, welcome to another tutorial video. In the last video, we talked about the automotive software testing, what that means and how it should be done. Also, we talked about the V cycle used in automotive field to develop and validate the software. Now, we will take an example of project, a small project, and then we will apply some technique in order to validate or test a software of an ECU. Okay, so it's an example of software testing project. We call this project ECU doors because we need to validate the ECU that manage the doors of the vehicle. So we will create a CAN simulation and automated testing of this ECU by using some tools, vector tools. We will use Cano, of course, and VTest Studio to develop the automated test case. Okay. So the project we will divide it into these main steps. The first thing is to create the simulated ECU with a single CAN network. In our case, we will have one CAN network. One network is CAN. Then we need to simulate the remaining bus which is required for the simulated ECU. So we need to simulate other ECU that will interface with our doors ECU. And the last step is to develop some test cases in VTest Studio and import them or launch them by Cano. So the test case will be developed in VTest and launched by Cano. So in reality, our ECU under test will be a real ECU, not a simulated ECU. But in our case, we will work with the simulated ECU. So no need to test this behavior in the lab. But in general, if you are in a big company or if you are in real projects, in a real company, in a big company, you should validate the real ECU. You can simulate some input, but you need to work with the real ECU if you want to validate it in the bench, of course. Okay. So we have other ECUs that we will interface with our ECU under test. We will have engine, console, and those will be the system under test. We need, of course, at the beginning to create our database, which will contain all the messages exchanged between the three ECUs and simulated the bus, which will connect them together. For the test case that will be created in VTest Studio, we can create them in couple code using a C# language, or by creating test table and test sequence diagram. This is some kind of format that we can choose them to develop our automated test case. Okay. And at the end, we need to compile all the test cases in VTest Studio and import them in Cano. And then we are ready to launch them. So Cano and VTest tools work together. Okay, this is a small description of our example of projects, ECU doors. Here you can find a presentation of the canvas that link the three ECU. We have engine ECU, send velocity and engine status to the CAN bus, to the other ECU. We have a console ECU that can send requests, and we didn't do a request to the other ECU, example for our doors ECU. And the ECU interface can also exchange or send some states. For example, the look state of the window and the position of the window in the CAN bus, and that will be received by the other ECU around this CAN bus. So the way of this communication will be clear in the requirements. Okay, keep in mind first just the form of how the communication should be done, but when and how engine status should send velocity engine and engine ECU, sorry, it should send the velocity and the engine status. When and how we will discover in the requirement definition. Keep in mind just this format for now. Okay. If you work in a big project, you can have many ECUs. Also, you can have some sensors. Some sensors can send some information, and your ECU will use this information as an input. You can have also some actuator extra. Okay, it depends on the project, but for our project is simple. We have 3 ECU. So as a software tester, the software tester need to clarify at the beginning the software requirements. The software requirement should be in official documentation format. If you are in a company, a professional site, you should have all the documentation that describe all the software requirements for each module. As you see, for each software requirement, we have an ID. The goal is to identify each software requirement, because at the end we need to perform some traceability between the software requirement and the test cases that validate them. Okay, so keep in mind, first step, we use the software requirements of the project as the input. Okay, the software requirement describe how the communication should be done between the ECUs, how the software should works, what are the inputs of the software, what are the outputs of your software. It can give you an idea, first idea of your software, and of course you can use this documentation to write your test case to validate the software. Okay, as I said before, for the big project, if you work for some OEM or for some supplier, you will have official documentation validated with the customer, and the team who develop this requirement can be usually it can be a software team. You can have 1, 2 or 3 or many guys that work to develop this requirements and deliver them to the other member of the team. Okay, so this is the input of the validation, but also input of the software developer. So it's the input of the software tester, and also input for the software developer. He can use this documentation to develop his software by developing some, for example, Simulink modules or some C codes. Okay,